Hi, it's Mr. Tush over at Global, and we're going to take a few minutes now to talk about the Create Performance task. Please use this video as a reference because you get a big piece of paper that we gave you in class. It looks like this, and this is downloadable on the class website if you lost your copy. But I'm going to also go over what's there, so if you kind of lose track of where things are, you can take a look at this video and review it a few times because I know it's a pretty big task, pretty daunting at times, but you can do it. Now, the first thing to look at is what do they want? Well, the nice thing is they did make that clear. They want a video, they want individual written responses, and they're going to want to see your program code. Pretty straightforward. We can do that. Oh, a little crazy with the highlighter there. They want the program code. So these are the three things they want. Program, the written responses about the program and development process, and the program code. Pretty straightforward. So that's the first thing it wants. Now, the app has to include, let's take a look at that. Now, the app has to have a few very special things. One, it says use of several effectively integrated mathematical and logical concepts from the language you are using. So it wants math and logic blocks. That's what it's looking for. It says implementation of an algorithm that integrates two or more algorithms and integrates math and logic. So we have to have math and logic, and we have to have what's called a nested algorithm. So that's one of the things we're looking at. Several mathematical and logical concepts, which means make sure you're using math and logic blocks. And then implementation of an algorithm that integrates two or more algorithms. That's nested algorithms. And then finally, development and use of abstractions to manage complexity. What they're saying there is they want procedures. So we're looking for math and logic blocks and nested algorithms and procedures. Let me show you a couple of quick things. When we did Logo, we did tons of procedures. If you remember, when you ran your Logo, you had square 100, you had loops and stuff and procedures that ran you to different parts of the square. That's an example of a procedure. You have lots of procedures. This was one of my Create tasks from the training that I took. And this is an example of a nested algorithm right here, this list picker. It says if the person selects sit, call the procedure sit visible. If it's not, then go over and look. If it says lay, call lay visible. If it's neither of those, go back and see if it says stay, call stay visible. And if it's not sit, lay, or stay, then it must be calling for the come command, so it goes to that. That's a nested algorithm that manages all of that. So that would have, for example, determined how it works. Now, the video and the write-up. That's the two things you're going to give us, the video and the write-up. Now, it's an awful lot that goes into the write-up. And the video itself won't take long to record, but you have to have a fully functional app in order to make the video. The video, once you get your app running, it's less than a minute. It demonstrates the app running and it shows one significant feature. We've done this before. You had to do this for your Paint Pop, where you said this is how it works and this is one thing I programmed into it. So you know how to do this already. Now, 2A, it's less than 150 words. Let's go over to this. Now we're talking about the written responses. This is the video, and this is 2A. It says identifies the programming language, identifies the purpose, and explains what the video illustrates. And that's all the stuff that it does. Identifies the language, identifies the purpose, and explains what the video illustrates. It's all you have to know. 150 words, and you really won't need that much to get that done. That's fairly straightforward. Now, the next thing you're going to look at is describe the incremental and iterative development process. That one is an important thing. Then focus on two distinct points. Describe difficulties and/or opportunities. They really are looking for that. So describe difficulties and/or opportunities you encountered and how they were resolved or incorporated. That's really important. They want to see difficulties or opportunities and how you solve them. The other thing is make sure that they know if it was collaborative or independent. So that's really important to see as you look at it. They want to know which parts were collaborative and independent. And then the last thing they're telling you is at least one of these points has to be independent. So make sure you're doing that. So on this incremental and iterative process, how you did it, focus on two specific points that you hit. Describe them as either difficulties or opportunities, and specifically how you resolved them. and then describe which ones were collaborative and which ones were independent, so you can describe how you work together with your partner on one of them, but one of them you have to work on completely on your own. It's also important to realize, never mention the teacher in this. If you say you have to be completely independent on this, so if you say, I did this with the teacher helping me, they will fail you for this task. So that's why I have to let you work on your own in class and why you cannot receive help directly from the teacher for this performance task. Capture and paste a program code segment. This is 2C. Let's take a look at that. 2C is about your algorithm. You're going to capture and paste a program code that has an algorithm. It has to be one you developed independently, includes 2 or more algorithms, and integrates math or logical concepts. Where is that? It implements an algorithm. Code segment must be an algorithm you developed individually, must include 2 or more algorithms, and integrate mathematical and logical concepts. So, and you have to describe how they function. So, let's take a look at that in here. This is an example of that. This is an algorithm that includes 2 or more algorithms. It actually includes 4. It uses a math block. It also uses a procedure. So if I'm describing that, I'm saying this is an example of when I pick list picker, when I pick home off of the list picker, after I pick, I evaluate the pick. And if the pick is sit, I call the sit visible procedure. If the pick is lay, I call the lay visible procedure, and et cetera, et cetera. It evaluates that, and that's my logic, and I have to be able to explain that logic. Finally, your abstraction. And this, believe it or not, is not the most difficult piece. You're looking for an abstraction, and the abstraction must integrate mathematical and logical concepts. So when you did the abstraction, you have to include an abstraction that does math or logical concepts. And there are some of those in here. Definitely when we did these are abstractions, but you have to include some kind of math. So they're looking at a procedure that you designed that has a math block in it. And right here is mine, math or logic, I should say. Right here is an example of that, because this is a procedure and none of this is math or logic, but true and false. These are from the logic drawer. So this is a procedure sorry about that. Really? Okay. This is the procedure. Thank you for your patience, my friends. Go back to it. This is the procedure down in here, thank you for your patience, that calls this variable, and then it moves all the different verticals that I was using, these vertical arrangements to govern this app. And the reason it works is they will see the app working, and then they will see that I used logic blocks. So when you write your 2D, make sure you include the procedure, and make sure that procedure has to include math and logic. Make sure that's in there. And that's finally number 3, your code. This one's fairly easy. This is where you go back over to your code and you right click and you download the blocks as an image, because you're going to have to deal with your blocks as an image. And make sure you straighten them out a little bit. Make sure they're kind of neat, so you can, as you can see, when I put my code together as an image, I actually, sorry, I'm zooming a little too much. When I put the code together as an image, I put all of my algorithms together, I put my procedures together, so that when I talked about it, I could actually draw neat little squares around this. And when you have parts that are written by your partners, you have to comment on that. So I wrote these, I actually developed this entire thing independently, but let's say for a second that I wanted to acknowledge that my partner wrote a particular something. So let's go over here, and I would say, I wrote that this is navigation, but if I wanted to comment that this was written by my partner, I would write in, these algorithms were developed by my partner. And I might want to say that, and then I would go over here saying, add comment, this procedure was developed independently. So, as you can see, I just mark it for the reader so they can see which parts are developed by your partner, which parts were developed independently. It's incredibly important when you're developing this. So comment it out, make sure your procedures and abstractions are all marked with the proper shapes. When you do that, follow these directions down here, mark with an oval that implements the algorithm. The rectangle is the abstraction, and then comments or acknowledgments for the stuff that was written by someone else. Do that, and you've got your project all set to go. This is due when the due date indicated on the website. Hope that helps, and good luck.